Hello and welcome back. In one of the previous videos, I already mentioned the cementing process. Today, we are going to discuss it in detail. As with drill a well, we need to reinforce its wells so that they would not cave in. For this purpose, we use casing pipes, and the annular space between the pipes and well walls is filled with cement. Let me remind you about various types of casing pipes. The topmost one is the conductor, which runs from the surface to the 60 meters depth. It is followed by surface casing, which is later attached to well control equipment that prevents blowouts. Depending on the geology, for example, we may have to isolate abnormal pressure zones. Surface casing strings may be used. Production casing is run the last. It is used to lift produced fluid up to the surface. Cementing process is one of the most technologically challenging procedures in drilling. We need to prepare tons of cement slurry. For example, a 2.5 kilometer well requires 80 tons of cement, and pump everything into place before the cement starts setting, that is, in an hour and a half, 2 hours tops. How do you do it? Powerful cementing pumps, which can produce pressure of up to 320 atmospheres, are installed on the well pad, along with mixing units. Special cementing head is installed on the wellhead. First, we pump in the slurry and then drilling fluid, which forces the slurry to go further down the well and up into the annulars. The slurry and the drilling fluid are separated with a rubber plug. The plug goes down through the whole production string length, and at its very bottom is stopped with a special lock ring. This moment, then the annular space is filled with cement slurry and the casing itself is filled with drilling fluid. It's called the stop signal. It's time to shut in the well and wait for the cement to set. You already know that after the well is drilled, special casing pipes are lowered into it and fixed with cement. The well may have crossed various porous reservoirs interbedded with impermeable formations. These reservoirs may contain oil, gas, water, or nothing. That is why special attention should be paid to well bottom hole construction. The following designs are typically used in drilling engineering: casing, screen, cement, pucker, perforations, producing reservoir, liner. We can install a water shutoff screen at the top of producing reservoir and cement it. Afterwards, we drill through the reservoir and install a special screen or liner. In some cases, then the producing reservoir is built of stable rock, no screen or liner is installed, and the water shutoff screen serves as a production screen as well. They can also drill through the whole producing reservoir, install a combination string with coiled cementing about the paste section and screen in the lower part against the reservoir. Another option is to drill through the whole producing reservoir, install and cement casing all along its length, and then perforate pay intervals. In all cases, the idea is to prevent pores from plugging and create favorable conditions for oil and gas inflow into the wellbore. But if you run a casing string and cement it all through the well, from the top to the bottom, how can reservoir fluid enter the wellbore? We need to create special channels for the fluid. They are called perforations and created using special guns called perforators. Perforators can be charged with bullets or shaped charges. They work like this. The loaded perforating gun is lowered into the well on a cable. Then, electric current is applied to the charges, the gun powered explodes and forces the bullet through the casing wall and the cement, creating a channel. Length and diameter of this channel, as well as other perforation properties, can be calculated using special equations. In one trip, a perforating gun shoots 6 to 12 perforations using 11 mm bullets. Instead of bullets, shaped charges may be used, which create a focus jet piercing steel, cement, and rock. To create better quality channels, the so-called abrasive perforation can be used. Abrasive perforator is lowered into the wellbore on a tubing string. A mixture of liquid and sand is pumped through the perforator with a force so great that it cuts through the casing, cement, and rock. This perforation method has multiple advantages. It creates very neat channels with high precision. We can control diameter and length of perforation channels. We can even make horizontal or vertical cuts. On the downside, this method is very expensive and requires lots of bulky surface equipment. How exactly we penetrate the producing reservoir depends on reservoir pressure, saturation, degree of drainage, and many other issues. However, the following rules should always be observed. When we penetrate an overpressured formation, we need to be very careful to avoid blowout. We need to minimize damage to the near wellbore area. If the rocks are of poor permeability, we also need to stimulate the near wellbore area for better inflow. We need to make sure that the producing reservoirs will be operated for a long period with minimum water cut and maximum oil and gas production. After we drill, case, cement, and perforate the well, we lower production tubing into the wellbore and initiate fluid inflow. This whole process is called well completion, as we kind of complete the construction stage and bring the well online. To initiate fluid inflow, we can drop the bottom hole pressure below the reservoir pressure, forcing the fluid out of the formation. To do so, we can either decrease the hydrostatic pressure of the fluid column inside the wellbore or use a pump. After the well has started flowing, production people take care of it further on, and the drilling rig is moved to a new location. This was a very brief and general description of well construction process. Now you know that drilling is a hard, demanding, and even dangerous job. But without drilling, it will be impossible to produce oil or gas. Next week, we will talk about production technology, how we operate wells, and what are advantages and disadvantages of various production techniques. See you!